Hello students, we will conservative vector fields example test for conservativeness of a vector field. So this is the example. Show that the vector field vector f equal to e to the power x cos y plus yz times vector I plus xz minus e to the power x sin y times vector j plus xy plus z vector k is conservative. So how do I prove conservativeness? Simple, there is a test. So call this m, call this n, and call this p. Okay. So this is your m, this is n, and this is p. So to check conservativeness, we have to prove dou m by dou y equal to dou n by dou x, comma dou n by dou z equal to dou p by dou y, and dou p by dou x equal to dou m by dou z. So this is what is meant by conservativeness. So let us look at dou m by dou y. What is this? Dou m by dou y is e to the power x minus of that times sin y plus z. And what is dou n by dou x? What is dou n by dou x? It is again z minus e to the power x sin y. So they are equal. So we have proved this. Similarly, dou n by dou z. What is this? X minus 0. And what is dou p by dou y? Dou p by dou y is x plus 0. So both are equal. That means we have proved this. And finally, dou p by dou x equal to y, and dou m by dou z. Dou m by dou z is again y. So they are equal. So this proved that f is conservative. So this is done. Now you have to find a potential function. Potential function means antiderivative, small f, such that capital F is equal to del times small f. To find potential function means small f such that vector f equal to del times small f. Remember, the potential function small f exists if and only if it is capital F is conservative. This happens if and only if f is conservative. This we have proved already. I think only one implication we have proved. The other implication is not in the syllabus, or it is beyond the scope of your syllabus. So already we have proved it is conservative, so this f exists. I have to find the antiderivative of capital F. So what is f? F is e to the power x cos y plus yz times vector I. That is my m, mi plus nj plus pk. M and p are given to you, and that is equal to del of small f. What is del of small f? It is dou f by dou x times vector I plus dou f by dou y times vector j plus dou f by dou z times vector k. Such an f you have to find out. So I want this to be equal to dou f by dou x vector I plus dou f by dou y times vector j plus dou f by dou z times vector k. This is what you want to find out. Small f such that this equation holds. This equation holds. So you have two vectors are equal. That happens if and only if first components are equal, second components are equal, third components are equal. So m equal to dou f by dou x, n equal to dou f by dou y, and p equal to dou f by dou z. Fine. You want to find small f such that these three equations hold. Now look at the first equation. I want small f such that the first equation holds, and m is given to you, you know, that is dou f by dou x, first equation gives dou f by dou x is equal to, what is your m? It is e to the power x cos y plus yz. So you want a function small f such that its partial derivative with respect to x is precisely e to the power x cos y plus yz. So what is that small f? Therefore small f equal to, f is a function of x, y and z. You integrate the right side with respect to x, keeping y and z fixed. Okay, so you integrate e to the power x cos y plus yz, thinking of y and z are constants. So integral of e to the power x is e to the power x. Y is a constant, so cos y is also a constant. Plus yz is a constant because y and z are constants. Times integral of what? What is integral of 1? It is x. So xyz plus a constant of integration. Let us say phi1. That constant of integration will depend upon the y and z which we have fixed. Okay, so if another person has fixed some another y and z in the domain of capital F, then his constant will be different from your constant. So that constant definitely will depend upon y and z, but it will be independent of x, that is for sure, because you are integrating with respect to x. So constant of integration will be independent of the variable of integration, where phi1 is the constant of integration depending on y and z, which has to be determined. Phi1 is to be determined. Okay, so this is what you get from first equation. Now you use second equation. Second equation gives what? So this is your f, and dou f by dou y equal to n. So you differentiate this f with respect to y and equate with n. Okay, so dou f by dou y, what is that? Minus e to the power x sin y dou f by dou y equal to minus e to the power x sin y plus z not z, xz plus xz. See, this is your f. You differentiate that with respect to y. So what you will get? Minus e to the power x sin y plus xz plus dou phi1 by dou y, and that must be equal to your n. What is your n? N is xz minus e to the power x sin y. This is your n. So here you have xz, here you have xz, they can cancel, and here minus e to the power x sin y, and here also minus e to the power x sin y. These two terms can cancel. So dou phi1 by dou y is equal to 0. This implies dou phi1 by dou y is equal to 0. So what is phi1? Therefore phi1 is phi1 is independent of y. So phi1 depends on z only, because already phi1 is independent of x. Now we have shown that phi1 is independent of y also from this equation. So phi1 depends on z only. So this implies phi1 of y comma z equal to some phi2 of z, right? Because it depends only on z now. Therefore, from this equation, f of x comma y comma z equal to e to the power x cos y plus xyz plus phi2 of z. F of x comma y comma z equal to e to the power x sin y plus xyz plus phi2 of z. Sorry, it is cos y, not sin y. So let me make that change. This is cos y now you use third equation, which we have not used so far. So third equation gives dou f by dou z. Dou f by dou z. From here you can compute dou f by dou z. So what is that? With respect to z, differentiate. So you will get xy plus derivative of phi2 with respect to z. That will be phi2 dash z. Here partial derivative becomes the ordinary derivative, which is equal to, what is dou f by dou z? That is what third equation says. Dou f by dou z is p. What is p? What is p? P is here. Yeah, this is p, xy plus z. So this is equal to xy plus z. So you can cancel this and this. So you will get phi2 dash of z is equal to z. This implies phi2 of z equal to z square by 2 plus a constant of integration. So we have determined everything. F of x y z. Yeah, here it is. Therefore f of x comma y comma z equal to e to the power x cos y plus xyz plus phi2 of z is z square by 2 plus constant. This is the answer. How do you verify that this is the answer? You compute del f. How do you verify? Compute del f and see whether it is equal to your capital F. So this I am leaving to you. Do it. Verification. For examination you don't have to verify it. It is for your satisfaction. I am asking you to do it. Thank you.